Hello team and welcome back to the channel. So today is day 6 of our Python for DevOps series, and today we are going to cover networking basics of using Python. Okay, so in networking basics we are going to understand what are IP addresses, subnets, then we are going to learn about ports, protocols, HTTP and HTTPS, then we are going to understand what is DNS, then firewalls and routers. Okay, this will be the networking basics that we are going to understand with examples, and then we are going to jump for Python for networking part. So in Python for networking part, we are going to understand different Python libraries that are used for networking in the DevOps context. Okay, I'm gonna give you examples as well as explain you what each library is used for and how we can use it in our Python scripts. Okay, so yeah, that will be today's agenda, and yeah, make sure to subscribe to the channel. It takes a lot of hard work and effort to create such hands-on content for you, and as you know, like I keep creating multiple courses for free on YouTube as well. Okay team, so talking about IP addresses and subnets. So IP address and subnets are fundamental concepts in the computer networking. They are used to identify as well as organize devices on different networks. Okay, now let me explain you about this in detail. Okay, so first of all, IP is short for Internet Protocol. Okay, and IP address is a unique numerical label assigned to each device that is connected to a computer network. Okay, an IP address can be used for two different purposes. Okay, first purpose that it is used for is identifying a device. Okay, and let me explain you. Yeah, so first purpose that IP address is used for is identifying device. Second purpose is locating a device. Okay, so basically what happens, as I said, IP address is a numerical label, okay, which will be assigned to every device that is connected in a computer network. So when we have a specific, that label will be unique for each device. Okay, so if you know, so that label, it is going to be like you can say a home address or IP, home address. Okay, and it looks something like this. For example, if we have IP address, let me give you one example. So that IP address may look 192.168.1.2, something like this. Okay, so as you can see, this is a unique IP address that will be assigned to a computer network device that is in computer network. Okay, and using this unique IP address, we can basically identify a device. Okay, it's like a name assigned to a device. Okay, then we have locating a device. Okay, so what happens that basically when you have the IP address already available, then through like understanding the IP address, you will find the network on which the device is existing, and through that you will understand the device location or network segment. Okay, so IP address will help in that thing also. Okay, so now you got to understand like what is the purpose of IP address, right? Okay, now let us talk about IP address like types. So basically there are two kinds of IP address that is available. Okay, first one that is available is known as, the format is known as IPv4. Okay, so that is one type, and second type that is available, it is known as IPv6. Okay, these two are basically formats available. Now in case you are wondering what exactly they mean, so IPv4 means Internet Protocol version 4. Okay, this means Internet Protocol version 4, while this IPv6, it means Internet Protocol version 6. Okay, but most commonly you will only see IPv4. Okay, because it is one of the most, like, it is most commonly used. Okay, and let me make you understand what exactly is the difference. Okay, so this kind of IP address which you see here, this is a kind of IPv4 address. Okay, and let me explain you why I am saying it's IPv4 address. So okay, as you see, if I zoom it, as you can see, there are like basically four parts. First part is 192, second part is 168, next part is 1, and next to next it's like 2. Okay, and you need to understand this thing, that each part is made up of 8 bits, right? So if one part is made up of 8 bits, 4 part 32 bits, right? So IPv4 address is made up of 32 bits, that you should know first. Okay, first thing, right? Okay, and see, The thing is the IPv4 address, IPv4 IP address, it is the most widely used version and consists of 32 bits, typically represented at 4 decimal numbers separated by periods or dot, which you can see, right? And this is IPv4 address, right? Next, talking about IPv6 address. Okay, IPv6 address. So what exactly it is? Okay, so this IPv6 address, you know, like if you are having this IPv4, so there will be a limit on number of devices that can be assigned with different numbers, right? Because each device is supposed to have a separate and unique number, correct? So if we are having that, then there will be a time where all the numbers will be exhausted and we cannot assign any new addresses to new devices, other devices, right? So in that case, IPv6 was introduced to address the, excuse me, yeah. So IPv6 was introduced to address the exhaustion of IPv4 addresses, okay. And here IPv6 address, basically it uses 128 bits. Here you see there are like 4 parts with each part as 8 bits. Here total is 128 bits, okay. And basically inside here we have how many parts? Let me just give you one example. Let me quickly search it because I have not noted down. Basically, 1 second. IPv6 example. So I can explain you a little bit. Yeah, see, this we can take the example and let me paste it here. Okay, now as you see, this IPv4 address is very small, while IPv6 address is quite long. 1 part, 2 part, 3 part, 4 part, 5 part, 6 part, 7 part, 8 part, right? So you can see like there are so many parts in that, and IPv6 is introduced only when the IPv4 addresses are exhausted, okay, and there is no one else, okay. So yeah, IPv6 is that, but yeah, as I said, IPv6 is not commonly used. Most widely we use IPv4, and whatever things we work in future in Python or DevOps or anywhere, we are going to work with IPv4 addresses only, okay. So this much you should know, correct? Okay team, so talking about subnet, what exactly it is. So subnet is a logical subdivision of an IP network, okay. It allows network administrators to divide a larger IP address space into smaller, more manageable segments, okay. And it is very essential for efficient network management, and it can also improve security and as well as the performance, okay. And basically in subnet there are two more most important components, which is subnet mask, and we have another one which is subnet ID, okay. Let me write it down. Yes, so let us discuss about subnet mask, what exactly it is. So subnet mask is used to determine the network portion and the host portion of an IP address, okay. So since you know like IP address is usually a 32-bit number if you are talking about IPv4, excuse me. Yes, so we can write in a format where we can write in a CIDR notation format, and then we can understand which one is the what part of this IP address is network part and what part of this IP address will be the host part, okay. For example, let's say we have an IP address information available like in this format, okay. Let's say I have this IP address will be like 192.168.1.100, okay. Let's say I have this IP address written as in CIDR notation, we can write /24, okay. So if we have written our IP address in this format, how do we understand, what do we understand by seeing this, okay. First of all, what we understand by /24 is that 24 bits are fixed and rest of the bits is variable, okay. That means an IP address, IPv4 address is 32 bits and initial 3 part 192, 168. So these are like one part, second part and third part. So till these 3 parts the IP address is fixed, okay, and rest last 8 bits it is variable. That means initial 3 parts, initial 24 bits is going to be fixed, and that is going to be of network portion. Rest is going to be for host portion, okay. And when we talk about like subnet mask, so like how exactly do we write it? Okay, so if we got to know information that 24 bits is fixed, so we can write in this format. And the subnet mask will be 255.255.255.0, and this will be the subnet mask. Okay, in case you are wondering from where it is coming 255, so basically each bit is written in the format of ones or zero. Okay, for example, let's say I can write in this format like a minute 33678 dot 5678. Okay, so each part basically denotes it can be written either 1 or 0. Okay, which will be the 2 to power. Okay, if like it's like here, then end like first one will be 2 power 0, second one 2 power 1, like that. So if everything is 1, then it comes 255, right? So yeah, so when we talk about subnet mask, and we know that we just need to know slash how much. So if it's written slash 24, so that many bits we are going to make as 1 in this part. Okay, here like sorry about that, 1 second. Yeah, oh my god. Yeah, so here you can see like 2 decimal parts I have written 111, and here, but we here got like here total 16 bits I kept 1, but here it's 24, so we will write 1 2 3 4 5 6 7 8. Okay, and rest will be just a 0. Okay, whatever, like a total 8 bits should be there. So this will be the, in this format we write. Okay, that is why we have, like when we got to know that 24 bits are fixed for our subnet, that means initial 24 bits we will just keep as 1, which will give the output as 255, and a last bit will be 0. Okay, and this is known as the subnet mask. Okay, let's talk about subnet ID. So subnet ID is the part of IP addresses that represents the network within the subnet. Okay, so how do we write it? So for the subnet ID, we are going to write it. We are going to write this one. This part will be, let me copy this, paste it here, and the subnet ID will be, we can write it in this format, 0. Right? So you got to know like how we will write subnet mask and subnet ID. Subnet mask we will write based on how much written after slash. If it's 24, then 24 bits we will just convert to ones, and if I convert like complete 24 bits to 1, it will come like 255. In case you are wondering from where this, why we are writing 111, so for each bit you can write 1 or 0. Okay, so for example, talking about, let's say this one, first bit. Okay, so if here if we write 0, okay, 1 second, sorry, each bit basically denotes the 2 power. Okay, so first one, if it's like 1, that means 2 power 0 equal to 1. Okay, then here let's 2, so 2, sorry, yeah, 2 power 0 1, then here first one will be 2 power 1, which is 2, same as like at the end, which will be coming as 2 power 128, sorry, 2 power 5, which will be coming as 2 power 5 or 6 or 7, I guess it comes like 128. Okay, so in this format we are writing it. And so if you got the IP address, so few things that you can find out easily. First of all, if you have the IP address, you can understand, if you got to know slash 24, if it is written in CIDR notation, that means slash 24, we got to understand that its IP address is subnet mask of that IP will be 24 bits fixed, which will be 255. Okay, and last bit will be 0. Same thing when we talk about subnet ID. So we will just like the fixed values, whichever they are, we will just write it down, then dot 0. This will be the subnet ID. Okay, now let me give you a real example. So let's say let's talk about, yeah, about this example only. Okay, so when we got to know it's like slash 24, so what will be the range of IP addresses that will exist? Okay, that means how many devices will be existing here. So that how we can write it down. Let me show you that as well. Yes, so that will be from here, like 0.1 at the end, you can see 0.1, 2 will be having till 1 second, 254. Okay, because as I told, it's from 0 to 255, so 0 and 255 they are fixed. Okay, so this means any device that has IP address in the range of from this one, in the range of from here to here, that will exist in our this specific network. Okay, and this is the subnet. Got it? Okay. Now let us talk about another thing which is known as ports. What exactly is port? So like when you have a virtual machine, okay, and when you install any tool, for example, let's say I install, one second, let me put it some here. Let's say I installed Jenkins. Okay, so to make sure that we are able to access Jenkins, we need to open a port, because one application inside a VM will run or will be accessible on a specific port only. Okay, so what usually we do, we will open a port 8080. Okay, so once we open a port is like a door, basically door to our whichever application. So like once we open the port, the application will be accessible on this port. Okay, like we can access the application by writing the IP address colon port, right? That is the general format. In this way, like let's say this is the IP address colon and port. In our case for Jenkins it will be 8080, right? Let's say I have deployed an application here. Okay, it's like deployed application. So once the application is deployed, that also should be accessible over specific port. Okay, we cannot directly just access the application because we have deployed it inside a VM. To make sure that it is accessible to us, we need to open a specific port. Let's say I will open a port like 9000. Okay, so now to access this deployed application, what I can do, I can write IP colon 9000 in my browser, and then this application will be accessible. Okay, that means for accessing each application inside a VM, you need to open a port, because everything that you install inside an application, like specific like Jenkins, Sonar, Cube, Nexus, this kind of application, they will be accessible only on a specific port. Okay, and here what you need to remember is the port range. Port is having a specific range which exists from 0 to 535. This is the range, that is the maximum number of ports can be opened on inside a VM is this one. Okay, like 8080, 9090. So this many, like total this many ports you can open, right? Okay, so this is about the port section. Now let's talk about protocols. Okay, so whatever things happen over network that happen, they follow a specific rule. Okay, they follow a specific protocol, and accordingly they get transferred or do whatever. Okay, so basically two of the most important protocols that we have, and first one is TCP. Okay, TCP /IP. Okay, and it is short for transmission control protocol, or you can say internet protocol. Is the foundational suite of protocols that govern the internet. Okay, over internet, whatever network related task happens, that follows a specific protocol, or you can say rules, you can say specific set of rules, and that rules, this TCP/IP transmission control protocol / internet protocol, that governs all sorts of things. This protocol is used by all the networking tasks over internet. Okay, and inside this we have other protocols like HTTP, then we have SMTP, okay, then we have FTP. FTP is like file transfer protocol, and these others you already know, like SMTP is used for like email specific port is there. Okay, when you want to send email messaging you want to do, then we use SMTP port. Okay, and HTTP port, hypertext transfer protocol. So when we deploy applications, we can access our application using HTTP protocols. Okay, another protocol that we know that exists is known as UDP protocol. Okay, and this UDP protocol, basically it's a short for user datagram protocol, which is another transport layer protocol like TCP, but it is connectionless. Okay, yeah, so these two things that should know basics. These are the basics of protocol. Okay, then we have two more other things which is very like small things, but still let us just study a little bit about it, which will be HTTP/HTTPS. Okay, yes. Okay, so when we talk about HTTP, which is hypertext transfer protocol, it is used for transferring web pages. Okay, it works over TCP protocol. Okay, so like when we are working with DevOps and we are deploying applications, and we access our application, over HTTP. Okay, and since we are doing these things for demo purpose, then we do not configure any security for the deployed application, right? So then we access the application over HTTP, then IP address, then call on the port. Okay, but when we configure security aspect also, we use different certificates. Then there is a like secure version of HTTP which is known as this hypertext transfer protocol secured. Okay, and this will be this HTTPS, it will be using SSL or TLS certificates for encryption. Okay, so just note this one, like HTTP is like a hypertext transfer protocol used for transferring web pages, but it is not too much secure. When we consider the security part and configure like certificates, SSL certificates, then we use HTTP, then our application can work on over HTTPS. Okay, another thing that I want to know, I want to tell you about networking concepts is known as DNS. It is another very important concept in networking. So basically it's short for domain name system, and what it does, it will translate the domain names to IP addresses. Okay, for example, like when you want to, let's say, access Google, so you don't write the IP address of the Google, instead you write google.com. okay, but computer network, they do not know that this is referring to specific google.com, because they understand the IP address format, right? So for that we have DNS, which is domain name system. What it will do, it will convert this into the IP address of the Google, and then internet can understand, okay, user is trying to go to Google. Okay, so for that we have domain name system. Great. Okay, then we have firewalls and routers. So firewalls, I think most of you might already know, firewalls control the incoming and outgoing network traffic. Okay, for example, like every device that we used, for example, here itself we have this you can see this option, Windows firewall, like that. Okay, so from here we can decide, or we can restrict, or we can set which basically what kind of traffic can come to our device or not, and we can restrict those. Okay, so firewall is specifically used for like setting up those kind of settings, how much which traffic should be coming here, and incoming and outgoing traffic. Basically, in simple words, we can say that firewall control the incoming and outgoing network traffic. Okay, then we have another important topic which is known as routers. Okay, so routers are devices that direct data packets between network. So like if you want to establish communication between two different networks, then you will be needing routers which will transfer the data packets and establish connections. Okay, okay, so these are some of the basics of networking that you should know. And since we did not jump into too much detail, because we won't be needing that much. Okay, how much we need, we understand now. Okay, now yeah, so now what I'm going to teach you is Python for networking, and what are different libraries that we are going to use from DevOps point of view in Python. Okay, so let's do that as well. Okay team, so now let's talk about one of the very important library in Python, which is known as socket. Okay, so now we are going to use this library to create a network connection. Okay, so what I have done is I've created two files, server.py and client.py. Okay, basically what will happen, that server will send a message over a specific port and network, and client will receive that message. Okay, so let me explain you what I have written in the code. So first line, you can see it is import socket. Okay, which is basically we are importing the socket module. Okay, next line, what we are doing is creating a socket object. So this line, what it will do, this line will create a socket object using IPv4 address family, which is AF_INET. Okay, and the TCP protocol, which is sock_stream. So this socket will be used for communication with client. Okay, that is why we are creating a socket object. Okay, next up, what we are doing is creating a host and port. We are defining the host and port. So for local host, the default is default IP is 127.0.0.1, and port we are going to use is 12345. Okay, next what we are doing is binding the we are using a command server underscore socket dot bind. So what it will do, this script will bind the server socket to IP address, the local host IP address, it will be bind, okay, and the port 12345, okay. That means that server will listen on the local machine and on port 12345, okay. Great. So next command what we are doing is basically setting up the socket to listen for incoming connections, okay. So that is why we have, you can see we are using a listen function, okay. And you are seeing like we have written 5 inside the circular bracket. That means up to 5 connections can be queued, okay, they can stay in queue, okay. Okay, so next up what we are doing is simply printing a message indicating that server is listening, fine. So we are printing like server is listening, and we are using dot format host and port, okay, just to define that server is listening on this IP address and on this port, okay. So next what we are doing is creating a infinite loop to handle the incoming client connections, okay. For that we are using while, and yeah, then using like while true, that is like infinite loop, and because of this the server will enter a loop that will run indefinitely, continuously accepting client connections, okay. So that means this connection through from client will be received continuously without any interruptions, okay. Okay, next up what we are doing is accepting a connection from client, like we are going to, I'll explain the client.py also. So from there we are accepting a connection, okay. What will happen in that case, when a client connect to server, the accept method is called, okay, the method that you are seeing here, okay. So that accept method will be called, and it will block the execution until a client connection is established and returns a new socket, okay, which is client underscore socket, for communication with the client as well as with the client's address, okay. And next up what we are doing is printing a message indicating that connection with the client is like working fine or not. And then what we are doing is sending a message to the client. This is the main part. We are sending a message, hello client, this is the server, okay. And then what is happening is we are basically, what will happen, the server sends a simple message to connected client. The message is first encoded to bytes using UTF-8 encoding before being sent to the socket, okay. And finally what we need to do is basically close the client socket, okay. So yeah, so this will be the server py. We are going to send some message to client. Next up what we have done is created another file using the same module, library module, and let me explain you what I have written here, okay. Here also first thing is like we are importing the socket module, okay. Next up we are again creating a socket object, and this will be similar to the one that we created previously, okay, in server file, okay. Next up what we are going to do is connecting to server, okay. Here we are specifying that server it wants to connect, specifying the server it wants to connect by providing the server IP address, okay, which is the local host here, okay, and the port number. So from client we are defining that client wants to connect to server, and already we have defined the host and port, that is the IP address and the port. So client inside client also we are mentioning that, so that it can connect to the server, okay. And yeah, so client socket then connects to server using client underscore socket dot connect, and inside it we are mentioning host and port, as you can see, right? Okay, then what we are doing is sending a message to server. Message will be hello dot server, and then we are using a send message, and we are inside which we are converting the message to using the UTF-8 also, so that it can be received without any issue, okay. Then what is happening is receiving the data from the server, okay. Here you can see we are using the this module RECV, this module we are using, which will receive the data from server, and it will decode it using UTF-8, okay. And now whatever message we received from server, we are going to print it here, okay. You can see we are using data in the format of variable, and finally after the usage we are going to close the connections, okay. Now let me show you how we will actually test it. So what I'm going to do is create 2 terminals, okay. First terminal I'm going to start run the service by files, okay. We can run in this format, sorry about that, Python, then it will be service, okay. And you can see server, it is written as server, it is listening on port localhost IP address : 12345, which is the port we have given it, okay. in second terminal I'm going to execute the client. So next, like whatever message is coming or going, then we can see that Python, then client, run. Okay, directly you can see received the message from server. What was the message from server? Which is, it was hello server. Okay, and if yeah, we are in server only. Great. So this is how basically we can like create a connection, and then in this format we can basically like create client server architecture. Okay, it is very simple basic one, but yeah, this is how it will work. Okay, more clarity will be coming. I'll like put a detailed explanation of each command in the documentation, so you can refer it. Okay team, so talking about another very important library, which is known as request. Okay, so this request library, when in Python, this can be used for a networking part of Python. So basically it's very good when you want to make interaction, like you want to interact with APIs. Okay, and using this request library you can make API calls. Same thing we are doing here. We are basically making a get request to URL, okay, using the get function. Okay, and yeah, as you can see, this is existing inside our request library, because that's how we are calling it, request.get. Okay, so when you send a get request to this specific URL, so if it is successful, there will be a response coming from this URL, and specific response will be stored inside this variable response. Okay, so if the request was successful, we will get the status code as 200. Okay, we are using a condition, you can see if and else, and we can just simply print the response variable. Okay, if the response was like not 200 and not successful, then we can simply print that there was error. Okay, so let me save the file and let me execute it. Also one more thing team, before you use the request library, you need to run this command pip install request, so that you can install the request library. Okay, yes. So some information we received, and you might seem like this is a little bit different, but it is actually correct, because this is the response that we received from this URL. Okay, we can see this user ID and title. So that is coming because there was this some post, and from there we received the URL, received this information. Okay, that means it is working fine, and we are able to make proper API calls. In case of API calls only, you will see this kind of information: user ID, title, then body of that. Okay, so yeah, it's working fine, and this is how you can work with request. There could be more scenarios, but this is the basic example. Using request library, we can make get request. Okay, we can send get request, and we can interact through API calls. Okay team, so next up we wanted to talk about another library in Python for networking, which is known as Scappy. So basically Scappy is a very powerful packet manipulation tool that allows for creating custom packets and sniffing traffic. Okay, so using this library, basically you can send sniff or dissect packets over over IP address or so. Okay, so from the example, basically what I'm doing, first of all, I'm importing the Scappy. Then we have defined a target IP address where I want to send packets. Okay, and here using this IP, I'm crafting a ICMP packet. Okay, basically a ping request. Okay, and here once we send the packets, then we should be able to receive something, and that receive we are printing here. Okay, that response. Okay, so yeah, first of all, what we need to do is install this Scappy. So we can run the command pip install Scappy and run it. So yeah, you can see it is installing now, and yes, it is done. Same thing, like let me save this here, save this file. Okay, and let us run this Python. Okay, so it seems like we did not receive any response, but yeah, the main thing that we need to understand is, yeah, this, like, we are able to work with this. Okay team, so see, the networking with Python is little bit complex thing, but yeah, to understand it more, I'll I have created a proper documentation. I would request you to go through it to understand every different like libraries of Python networking. Okay, so yeah, that will be all for today, and thanks for watching.